This is Unit 1, Lesson 4, Making the Moves. And there are 3 activities in this lesson that I'm going to cover. And this image is actually from the first activity. This is a reflection of these black triangles. This black triangle is one base of a... Oh no, let's not talk about that. This black triangle is one image, and this other black triangle is a reflection of that image. And then when you color them in, you get these nice patterns, sometimes an optical illusion. It just looks nice. So I would suggest doing that as you go through these reflections. Now the activity is that students are given this page to start with. So there's a triangle. And then they're shown another image just briefly, and then they're showing it again just briefly. So they're showing this image briefly, and then it's taken away, and they're asked to draw that second image based on what they saw. And they're showing it again, taking it away, and they're asked to draw that. And so this is getting towards students recognizing the patterns in reflections in this case. So how do you use that pattern to draw that image? And so what they're trying to get students to do is to recognize where the line of reflection goes. And so when you look at this image, my suggestion is to, after you have some discussion with the kids, get them to focus on one region. Now it could be this region that's right here between the images, but this one is pretty easy to look at, and you can see that the angle of the line of reflection, it runs from one point through the square as a diagonal, then it continues up. And so once they see that, and once they realize that B in this case is just one unit away from the line of reflection, then they can draw this line of reflection. And once you can draw the line of reflection, then you can actually draw the reflection. Because in every case, you just have to connect the point with its corresponding point by drawing a line that's perpendicular to the line of reflection. That means that's at a right angle. And then you have to just match that distance on the other side. So I'm going to show you that in a moment, but I'm going to draw a line from A to the line of reflection that's at a right angle, that's perpendicular. And then I'm going to match this distance on the other side, and that's where A prime goes, the corresponding point. Now B you can see from the grid. B is one unit, and then B prime is one unit on the other side. And this is a right angle because this is the other diagonal going in the opposite direction. And D is also pretty easy to see. It's 2.5 units, 1, 2.5, and then a half, 1, 2. So it's an equal distance on both sides, and you want to look at lines or connecting, let's call them connecting lines that form right angles with the line of reflection. So once again, look for perpendicular lines, lines that form right angles, and look for an equal distance from the first point to its corresponding point. So that's what this is right here. Here's B, which I mentioned before, pretty easy to see for B. And then D, that line moves through the diagonals as well, the squares, and it's an equal distance on both sides. Once you do that, have a little bit of fun by coloring in the image and seeing what you see. Now, is this a reflection where this edge comes out of the page towards you, or does it go into the page away from you? And does it flip back and forth? And there was another illusion that I was seeing before, an optical illusion I was seeing before. I can't really see it right now. I think that this flips back and forth. Oh yeah, this is going out. This is going out, or they're both going in the same direction as if it's being a translation. Although it's certainly not a translation, but it kind of looks like a twisted translation. Maybe you could say it that way. All right, the second activity. There are 4 images in the second activity where you have to deal with 4 separate transformations. 2 translations, 1 reflection, and 1 rotation. So this first image, this is a translation from the blue figure to the green figure. And there is no angle. So when you talk about translations, you talk about the angle that it's translated at and the distance. Well, the angle is 0 degrees. There is an angle, it's 0 degrees. So it just moves along this horizontal line. And how many units does it move along? It moves along 6 units. So every point is going to move in the same way, 6 units along this horizontal line, and that's going to be the translation. And just like the reflection, my suggestion is to connect those points. And in this case, a translation is always going to give you a prism. The second base is always a translated copy of the first base of a prism. So this is the first base of a prism, and this is the translated copy. It forms the second base, and the corresponding sides are always connected by parallelograms. Now, if it forms a right angle, it's called a right prism. Before, I was calling that a rectangular prism. I was making a mistake before. Sorry about that. It's called a right prism. A rectangular prism means it has a rectangular base. This is a triangular prism and has a triangular base. All right, so each corresponding point is translated. The same distance, you want to look at the distance, and you want to look at the direction, what the angle is. And then I think it's always a good idea to look for the prism that is created. The second base is a translated copy of the first base, always. That is always true. All right, the second image is a reflection. And you kind of, as you look at it for a while, you can kind of tell it's not a rotation because this edge is going to end up on the far side. If you rotated it, it is a reflection. The line of reflection is right here. And so you're going to look for perpendicular lines, lines that form a right angle with that line of reflection, and the corresponding points are an equal distance from that line of reflection. So C is 1 unit away, C prime is 1 unit away on the other side. B, here's the right angle, the perpendicular line, and B is an equal distance from the line of reflection as is B prime, and the same with A and A prime. So here it is filled in. The arrows are perpendicular to the line of reflection. So the line of reflection is blue. And these arrows form right angles. They are perpendicular to the line of reflection. Corresponding points are an equidistant from the line of reflection. So B is an equal distance from this line as is B prime. So this is 2, 4, 5 units. This is 2, 4, 5 units. C is 1 unit, C prime is 1 unit, and A is 6 units, and A prime is 6 units. Again, I would color these in. If you color it certain ways, you see really weird optical illusions. I would suggest having some fun with it. And so all this work that I'm showing you, I do in Doceri. So if you get used to working in Doceri, things begin to be interesting. All right, the next image, this is a translation. Now this one is at an angle. So it's going from the blue figure to the green figure. Now a way to get there, you could just draw lines directly from the first point to its corresponding point and try to figure out the relationship. You might make a guess at how that goes. This goes kind of to the middle, maybe 3 units, 3.5. Yeah, it looks like it's 3.5 units, and then another 3.5 units. But it's messy. So what I suggest to do is you can count along the horizontal axis and then the vertical axis. So A prime is 7 units along the horizontal axis, and then 2 units along the vertical axis. B to B prime is the same, 7 units, 2 units. C is 7 units, C prime is 7 units, and then 2 units. So use the grid to record the distance and the direction. So you should write that out. Think distance and direction, then look for the prism. So here's the prism once again. Remember that the second base is always a translated copy of the first base. And if you colored in these faces, so the connecting parallelograms are called faces, colored them in, and you get a nice figure. All right, and the last image is a rotation. Now I covered this rotation in the extra video that I provided on finding the center of rotation. I'm going to go through that briefly once again. So how do you find the center of rotation to rotate the blue figure to the green figure? And it's going to be somewhere, oh, actually it's up here if I remember on this one. Now my tendency is to go down here and think, oh, it's going to rotate around here. You have to think of each of these as being tied to that center, just kind of swinging around. So how do you find that center of rotation? I actually initially made a mistake, and I want to leave that in here because I want to show you what happens in one example of making a mistake. So you connect the corresponding points. I connect A to A prime, B to B prime, and C to C prime. And you find their midpoints. So the midpoint for A to A prime is right here. B to B prime is right here. C to C prime is right, it's not shown on this one, but it's right here actually. And then you draw a line that's perpendicular. It forms a right angle from the midpoint of the lines. And you look for an intersection. Well, I started to draw that line going from here. I started to draw the line that's perpendicular in this direction because I was thinking that the center of rotation is this way. And so I couldn't find any intersection on the grid. Nothing really seemed to work very well. So then I went to the second one and drew the similar line that's perpendicular this way. And I realized, oh, these are going apart. I'm going in the wrong direction. So you have to flip it over. You can use the same midpoint. And the perpendicular line is just extension the other direction. So now you go this way, and it turns out that they intersect up here. And so the B to B prime, it's a line perpendicular to B to B prime, starting at its midpoint, goes in this direction, so this forms a right angle and intersects up here. Then you add C to C prime, and so all three of those intersect at that point right there. That is the center of rotation. Now you can go through a counting strategy to check. This is 2 over, this is 2 over. B is 2, 4, 6 over, and 1 in the direction of rotation. So then you rotate this 90 degrees, 2, 4, 6, and then 1 unit in the direction of rotation. I'm not showing you that in detail right now. I actually will a little bit later, but you can check by counting. So look for the corresponding points, find the midpoint. I'm using Doceri to find the midpoint. Doceri will snap a line to the middle of another line segment. It just snaps in place. And so that way you can find the midpoint, and then you draw the perpendicular line from that. So perpendicular line from the midpoint, and look for where they intersect at the center of rotation. All right, the third activity. You're supposed to transform A to B, so take A to B through a transformation. You have to decide what that is, and then B to C through a second transformation. So this is called a sequence of transformations. So to get from A to B, this is a translation. It's moving directly across, and so this point here is moving 2 units, 1, 2, to its corresponding spot. This point is moving 2 units, 1, 2, to its corresponding point. This point is 1, 2 to its corresponding point. The point in the back is 1, 2 to its corresponding point. And then to rotate, you have to figure out what the center of rotation is. And again, in that supplemental video, I'm going to tell you what that is. It's right here. It's this point right here, I believe. And it is. What I'm looking at is I'm counting 1, 2 diamonds, and counting 1, 2 diamonds to get to the very center. But I'm going to show you how you find that once again. So here's the translation. So just translate straight over. Each one of these moves 2 units over. And again, hopefully you're working in Doceri. Add a little bit of color. It brings things out. It makes things easier to see. But how do you find the center of rotation? All right, once again, you connect the corresponding points. So this point here corresponds to this point right here. I could have labeled them. Get a lot of stuff written in here. It gets messy. This point here corresponds to this point. This point here corresponds to this point over here, and this point right here corresponds to this point. Then you find the midpoint of each of those. This is the midpoint. Having trouble seeing these. This is the midpoint right here. This is the midpoint right here. And this one, the midpoint is right there. And then you draw lines that are perpendicular starting at the midpoint. So perpendicular to the lines that connect the corresponding points. It's a mouthful. Then you draw a line that's perpendicular and you look for where they intersect. And they intersect out here. And I already showed you how you can just kind of see it, but this confirms it. And then you could check this by counting. If I count along the edge of one of the triangles, this is 1, 2, 3 units, and then 1 unit in the direction of rotation puts me right there. Now if I rotate this 60 degrees and count 1, 2, 3 units, and 1 unit in the direction of rotation, it puts me at its corresponding point. So you go through and check each of them. You're going to find out that this is the correct center of rotation. Now you can say, I'm not going to go through B. I'm just going to rotate A to C as one rotation, as one transformation called a rotation. So now you have to find the center of rotation to do that. This is wrong. I'm going to tell you up front that I made a mistake because I want you to see what happens when you make a mistake when you go to check your work. So I was going through the process. I connected this point here to its corresponding point, went around, did the same thing. This point here to its corresponding point, this point to its corresponding point, and this point to its corresponding point. Found the midpoints. Actually, I left this one here from Doceri. I snapped this line, and then I just dragged it along this line until it snapped at the midpoint. So it just kind of sticks there. And then I know that's the midpoint, and I can draw a line that's perpendicular. I'm looking for an intersection that's out here somewhere that's going to work as a center of rotation. So all the other ones are going to meet at that point. And I can kind of tell that these are too close because I can tell where these other ones are going to start to line up. So I went out to this point here. And this one looks pretty good. So each of the lines, the perpendicular line, it looks like it intersects. They all intersect here, and it looks like they are all perpendicular lines. So everything looks good. But then when I checked it, it didn't work. So I'm going to count. I'm going to check by counting. So I'm going to count along the equilateral triangle here. And so this point here is 1, 2, 3, 4 units up. That means its corresponding point, if I rotate this 60 degrees, its corresponding point should be 1, 2, 3, 4 units up. And it's not. It's in the wrong spot. It's over here. Now, because I've been doing these for a while now, I can tell that I need to move this point down a little ways so that when I count up, I'm going to count up and then count over. And down here, I'm going to count up and then count over in the direction of rotation. So it looks like the center of rotation, the point actually goes off the grid. It's down here off the grid. So I put this on a expanded grid, got rid of all those points. Oh, actually they're right here. I'm going to get rid of them. And I'm going to draw new perpendicular lines that connect at this point. So if I measured each of these angles, you would find, or I would find, that they are not 90 degrees. They can't be 90 degrees. Made a mistake. They're close to 90 degrees. That would be a good activity. You know, how close are each of these angles to 90 degrees? But they're not going to be 90 degrees. The ones that are going to be 90 degrees are these angles. So they all intersect at this point here. So the midpoint, 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 midpoint. You draw a perpendicular line, which means it forms a right angle. They all intersect down here. And then you check by counting. Count up and over. So I'm going to check that by counting. I count up 5 units. 1, 2, 3, 4, 5. And 1 unit in the direction of rotation. I'm counting along the side of an equilateral triangle. Then count along the side of an equilateral triangle. And then count in the direction 1 unit, and you can confirm that this is in fact the center of rotation, and it takes A to C, this is trapezoid C, through a reflection.